All right, let me read and fully go over. Come on. So we are trying to graph the equation y equals cotangent of 3x plus pi over 2. Now, it works in the exact same way that everything has been working so far, where we have to find a, b, h, and k first. So, what is our a value? What's me, but I can't see anything. It just says presentation. But so on this example, what is our a value? Okay, yes, 1. What is the b value? 3. What is the h value? Mm, that's a k. Yeah, that's a k. And yes, you guys are right. Well, no, some of you guys are right. Take a look. Remember, to know our true H movement, we need to have the B outside of a separate set of parentheses. So we need to divide the 3 out of both of these terms. Pi over 2 divided by 3, what you do, whoops, is you just multiply the denominators. So it's actually pi over 6 is our, technically negative, you would say, because you're moving to the left pi over 6. So this is being shifted to the left pi over 6. Then our k was 2. Now what is our amplitude? What is our amplitude determined by? The a value. So our a value here is 1. Therefore, our amplitude is 1. What is our, or how do we find our period? Now, you might think it's 2 pi divided by b because on our sine and cosine graphs, that's how you find the period. But it's 2 pi divided by b on sine and cosine because on the parent functions, the period is 2 pi. Here, on our parent functions, what was the period? Pi. So in order to, right, yes, you guys are getting it. So in order to get the period on this cotangent graph, you take the parent function's period, which is pi, and you divide it by the absolute value of b. So it's pi divided by 3. Because our b value is 3. Now, how do you get the tick mark width? Yes, so that's where you get the first tick mark value. So this H determines your starting value, your starting mark, your first. But we need to determine how far apart the tick marks are because once I know this first tick mark, in order to get my second tick mark, I need to add the tick mark width to it. So how, if I'm looking up here at my parent function, if I'm looking at the first full period from 0 to pi, I took pi, and how did I get this first width? What is that? Yes, pi, yes. Oh, you guys are answering. Oh, I totally didn't look at the chat, I guess. I don't know. What you do is you take the period, which is pi in this parent function case, And you always divide it by 4 because there will always be 4 tick mark sections. Okay? So, where am I? Over here, what you do is you take your period, and you can even, if you think you're going to forget this, take your period and you divide it by 4. So our period here is pi over 3. Pi over 3 divided by 4 is pi over 12. Oh, yes. Pi over. So now, in order to get our next tick marks, what you do is you add the width to the previous tick mark. So in this second tick mark, if I have negative pi over 6, can I immediately add pi over 12? What do you need to do? Yes. So what you do is you multiply by 2 over 2. This will create the denominator of 12. So now you have negative 2 pi over 12. All we did here was we multiplied pi over 6, negative pi over 6 times 2 over 2 to get, oh gosh, what is this? To get this W. What? Ugh. And then we add the tick mark width, which is pi over 12, and we end up with negative pi over 12. That's where our second tick mark is located. Then we repeat. We keep going. We're now taking the second tick mark, negative pi over 12, and adding another pi over 12. And what do we get? Oh, ugh, why is this not working? What is negative pi over 12 plus pi over 12? 0. Good, good, good. So that's our third tick mark. And our fourth tick mark, we take 0 and again add the tick mark width of pi over 12, and you get pi over 12. And then we take the fourth tick mark, pi over 12, and add the tick mark width, pi over 12, and we get 2 pi over 12, which simplifies to pi over 6. Now remember that our period is pi over 3. So if we're looking between the first tick mark and the fifth tick mark from negative pi over 6 to pi over 6, that length should be the period, pi over 3, which it is. Okay, so now we have everything we need to graph this. Knowing that a cotangent graph, if I'm looking up here at the parent function cotangent graph, if I'm looking at the initial period that I was talking about, from 0 to pi, the pattern that happens here is we have an asymptote, a tick mark, a 0, a tick mark, and an F. This pattern for the initial period will always hold true. Always, always, always. What that means is if negative pi over 6 is my first tick mark, that's going to be an asymptote. Then I have just a plain tick mark. Then the middle tick mark is my 0. Then I have a tick mark. And my last tick mark is another asymptote. This pattern will always hold true for cotangent. Whereas tangent goes 0, asymptote 0. Cotangent goes asymptote 0, asymptote. So let's go ahead and graph it. First thing I'm going to do is graph my tick marks. Oh, this graph. It's going to be hard to graph this one because we're like right centered at 0, 0, and they have it way over to the right. It's okay. So I'm going to graph negative pi over 6. That's our first tick mark. Our second tick mark is negative pi over 12. Then we have our third tick mark at 0. Our fourth tick mark is at pi over 12. And our fifth tick mark is at pi over 6. So I need to place an asymptote on our first tick mark. An asymptote on 0, and an asymptote on pi over 6. And then my 0, oh shoot, why didn't no one yell at me? There was not supposed to be an asymptote there. That's where my 0 was. And my, oh, okay. And the last thing I need to concern myself with is the amplitude and also the K value. So my amplitude here is 1, meaning from my 0, I just go up 1 over 1, up 1 over a single tick mark. And my K value is 2. So what this means is my actual 0 is no longer on 0, 0. It is being shifted up by 2. And my next perfect point from that point is just up 1 over a tick mark. I'm sorry. Up 1 over a tick mark. And down 1 over a tick mark. I know it's this way because it is a cotangent graph. And I'm done. You could graph multiple waves. It's up to you, but this is all that is needed to get 100% if you were graphing this in class. You just need to graph a single wave. Are there any questions on? I know there's a lot to it. I know there's a lot to it. Luckily, like I keep saying, you won't have to graph on your curriculum test. You will just have to know what the graph looks like, or you'll have to know looking at a graph what the equation is for that graph. For problem number 1, on the same page, how come you don't have anything written for them? Because I was being lazy. Okay. The video is up. Oh, for this class. Yeah, for sure. Bye.